A while back, I made a video about one of these batteries and how to use a basic multimeter to get their voltage. This is a BMW 530e hybrid battery pack, and it measures 9.1 kilowatt hours and has nominal voltage of 351 volts. Inside of this box, there are 6 individual battery modules. As we learn more about hybrid cars and electric cars, we realize that a high voltage battery pack isn't always on, and it needs to be turned on in order for us to get electricity out of it. There's live electricity inside of this box, but there's a gatekeeper between that and the outside world, if you will. So we learned a while back that we can't simply connect a multimeter here to this output connector and read any voltage. Something has to happen inside here. Inside this box, there are 6 cell modules, batteries about approximately the size of a regular car battery. And in addition to that, there's something that BMW calls a safety box. A more generic term is a contactor box. It's essentially a device that has a positive contactor and a negative contactor and a pre-charged circuit inside of it, amongst other things. And you have to close both contactors to let the electricity to make the connection to the outside world, if you will. Thanks to the efforts of good folks on openinverter.org, spearheaded by Damian McGuire, we now have the ability to control that safety box, to control the contactor box, if you will, close the contactors on demand and open them back up or turn them off again. And so I want to take the time and use this code and see if we can take the lid off of this battery pack, connect what we need to connect, and read the data. So now, instead of using a simple multimeter, we will be using a laptop, an Arduino board, and a CAN bus transceiver, along with some code that you can download from GitHub for free. And we will try to interrogate and control this safety box. The code will allow us to read basic voltage, and it will allow us to manipulate the contactors, if you will, and the pre-charged circuit, allowing us to close the contactors on demand and open them. So what we will be able to do now is, using the laptop and the software, we can close the contactors, which will essentially allow the gatekeeper to let the electricity through to these connectors, and then we'll be able to just prove that the contactors are indeed closed and that we have electricity flowing out of the pack. Then we can connect the multimeter here, and then we'll get a reading. So the first thing we need to do is we still need to take the lid off. This is one of the challenges with this BMW battery pack, is that we are unable to connect to this outside connector just yet. We need to remove the lid, and inside of this box there are multiple components. On this side we'll see the safety box, and that's what we'll tap into directly. And on this side we have the BMS master control unit, if you will, and each of the 6 modules has its own slave BMS board. Once I get the lid off, we'll take a better look at what's inside. Okay, let's take this lid off. I hope that's all of them. If I remember correctly, this lid should not be stuck on there. It's not glued on there like the other lids of Nissan Leaf or the Teslas. The BMW just uses a gasket or a seal and it doesn't stick. So hopefully I don't look foolish for saying that. So here we go. Okay. So there we have it. 1, 2, 3, 4, 5, 6 cell modules. This is the safety box right there. And I will remove that rubber gasket. So as I said, this was not glued on there, which is actually pretty nice. Okay, so that part is done. Okay, so let's do a quick review of what's in this battery pack. Again, BMW 530e hybrid battery pack. And inside here, obviously, we have the 6 cell modules. So the cell modules are numbered, and what helps you out knowing which ones are which is on these connectors, they have numbers. So for example, this is number 2, and this is number 3. And just having taken this apart in the past, I know that there's number 1 underneath it. And then if we go to this side, we have, again, cheating, looking out here, this is number 5, this is number 4, so number 6 is underneath. What you will notice is that there's some aluminum piping here, and this is for the either cooling or the heating. I don't remember if BMW also heats its batteries or just cools them. I think if it cools them, it uses something just similar to your air conditioning fluid. So then we have, each module has a slave BMS board. Some are on the sides here and some are on top. This is really modular. It can be on this side, it could be on this side, it can be on this side of the battery, on the outside, or over here, depending how you want to configure it. And then all those slave modules report back to this master BMS. Okay, what else do we have? Well, we have the safety box right here. And if we look how this battery, these cell modules are connected, we'll notice that the number 1 lead is right here. Okay, and it runs all the way across into here. And then I believe from number 6, it comes out this way and runs over here. It can get confusing knowing which ones are positive and negative. So it can get a little bit confusing which one of these are positive and negative, so be careful, because the outside ones are what's coming to this port out here. All right, and if we look, this is the negative one, and then this one here is positive, but then the inside leads are opposite. So it's not negative, negative, and positive, positive. Okay, and this may make no sense to you right now until you get deeper into the safety box. But it's important to know which ones they are, because that's how the contactors inside there in very limited space use bus bars to pass the current and open and close these connections. Anyway, we can just remove these inside ones, which are what's coming into the safety box. And once again, just use a multimeter and take that reading. We may do that just to kind of do the belt and suspenders thing here. And then we'll unhook or disconnect this plug here and tap in with our own modified wiring harness, and we'll use the laptop to see if we can manipulate the contactors and get a reading via the laptop through this connector right here. Okay guys, I have the multimeter hooked up. I did this off camera because these things are an incredible pain in the ass to disconnect. And here we have a negative lead, and this is the positive lead. If you connect these and you're getting negative numbers, you simply just reverse your leads because you connected your multimeter wrong. Anyway, 346 volts. I think that's pretty good for a battery pack that sat in my garage for a while, and who knows how long it sat at the dismantler. So 346 volts, let's remember that, and we'll see what we'll see what the actual reading through the safety box says. Okay, so now that we've taken a basic reading with the multimeter of this battery pack, it has 346 volts. Now let's get down to business and get to the meat and potatoes of this video. What we really want to do is use open source software that was developed by the folks on Open Inverter, spearheaded by Damien McGuire, and he uploaded for us to GitHub. Those of you who are programmers familiar with GitHub, you know how all that works. It's where developers and programmers upload their software for the community to use, if you will. So it's a free download. It comes with some basic instructions. And so what we need is we need some hardware and we need some software. I will briefly talk about it here and maybe elaborate more in the video once I put it all together. So because it's software, obviously we need a computer to run it. So we're going to need a laptop. So here I just have a my trusty old laptop. And as you can see back here, we have a regular car battery. So earlier in the video, I said that although this is a battery pack, it's turned off, if you will, and needs to be turned on. And to do that, we use a regular car battery. A lot of people new to EV conversions or electric cars in general are a bit surprised to hear that electric cars still have a regular car battery. But this battery will supply 12 volts to this safety box, a ground and 12 volts, and then we'll go from there. So that's what the battery is for. Speaking of connecting to the safety box, I have made a simple harness. And when I say I made it, I took the harness that was in here from my first battery and I simply thinned it out per Damien's instructions. And it's fairly simple. This white connector here is exact same one as this one. And there are 4 wires coming off of it. 5, I lied. There's 5 wires coming off of it. Usually what happens is an electronic component will need, positive and negative. And so there's 2 red wires, and so both of those need 12 volts, and there's a black wire, which is our ground. That's going to give us power. And the other thing is control. And we're going to be using something called CAN bus. CAN bus, I say it stands for Car Area Network. It's like LAN, Local Area Network, or WAN, Wide Area Network. Anyway, if you don't know anything about anything and you see some wires that are twisted up like this, that may be a dead giveaway that they are used for something called CAN bus. And we will send commands using CAN to this safety box to tell it what to do. Okay, so in addition to the wiring harness, our laptop, and our car battery, next we need what is called an Arduino DUI, and this is a circuit board with a controller on it. And when you go out to get one, if you go out to get one, Arduino puts out a variety of boards. They have cheaper, smaller ones that are called Uno. I would say don't buy those. Buy the DUI. There's a bit of different architecture. And if you know what you're doing and if you're a savvy programmer, you'll figure it out. But just to make it easy on yourself, get the DUI. Also, I would not recommend buying the knockoffs, the aftermarket, the generic ones. the amount of money that you save is not worth it. Just get the name brand one, pay a little bit extra, and you'll see that will pay off when it comes to programming this thing, because you'll need to go to your laptop, download the code from GitHub, and then use Arduino IDE, integrated development environment, to save that code, if you will, onto this card. And if you get a generic one, sometimes the laptop doesn't see the card and it's a headache. Another thing that we have here is even a smaller chip, if you will, and I'll show you some close-up photos. And this is a CAN bus transceiver. It basically takes the signals from this card, which acts as a brain, and translates them into CAN bus so that it can send it to the safety box. Okay guys, I got it working, and I want to tell you here about my little setup. I think that maybe the best way to do it is using shaky cam. So let me walk you through what is happening here. So I unplugged the actual connector, and I'm using the exact same one just so I don't have to cut this one up or tap into it. But basically what we have from here, okay, first thing we have to do is give the safety box power. It's an electronic component. It gets 12 volts from the battery, okay? So 2 red wires, and there's 2 of them because I'm guessing maybe one is constant power or something like that, and the other one is like key on, you know, ignition on power. Regardless, these 2 wires loop around, but they're really running to a fuse here and then to the positive. Now, I'm going to share with you all the mistakes I made shooting this video, because it's been a while since I've played with CAN bus, and I think we learned from our mistakes. So first of all, I put a 3 amp fuse on there. Usually I use about 5 amps, but you know, these dinky electronics use a 1 amp, 2 amp. So I had a 3 amp on there, and for some reason it blew, and I checked everything but the fuse, and then finally I checked the fuse, and sure enough it was blown. So then I added a 5 amp fuse, and after using a bench power supply to temporarily troubleshoot that guy, it showed me it's only pulling 0.25 amps, so quarter of an amp. So 3 amps is fine, but now we're on a 5 amp fuse. So if you're getting frustrated, this isn't working, check your fuse, double check it. Okay, so we have our positive connection, and then the black wire coming off of this connector is simply negative, again, to the battery. Here I'm just using alligator clips, and it's kind of looping around because I wanted to separate CAN kind of to show you, but it's pretty simple connection. Okay, so then back here we got the 2 red wires and the black one for power, and the other 2 wires are the sort of black, purple, and yellow with a purple stripe. This is CAN high and CAN low. So again, brutally honest, the second thing that bit me in the ass is anytime I work with CAN, I use yellow as low, yellow, CAN high, CAN low, yellow. It's just this association in my mind, and because of always doing that, I connected them backwards to the transceiver here. Okay, this has a little screw-in connection. Is this guy gonna focus? And on there it says CAN high and CAN low, but it's the opposite of what I normally do. Hope you can see that. I'm really sorry about this video. So the top one is CAN low, and it's actually the purple, and the bottom is CAN high, and it's the yellow. So make sure you get those right, because I got them backwards. And then the stupidity continued. Again, it's been a while since I played with CAN bus and Arduinos, and between the GMCe and the Arduino, I connected the RX and the TX, you know, the RX to the TX and the TX to the RX, but it's actually RX to RX and TX to TX. So I pretty much made all the mistakes, but you know, I'm rusty. I stepped away from the project for 6 months and now I'm back at it. So we have red for positive power, black for negative to the battery, and then we have the twisted pair running the yellow and the purple wires to the a little CAN bus transceiver. You get those on Amazon for like $9, and then for about $40 you buy this Arduino Dewey card, the green one. Don't get the blue one. The blue one usually means it's knockoff aftermarket. This thing is connected to the laptop with USB. It gets its power with the USB, and then it supplies 3.3 volts or something like that to this little transceiver. So it has a red for the 3.3 volts, the black for the ground, because this mothership supplies that little spaceship with power. And then it talks to it with this RxTX stuff, and then from here it talks to the safety box with CAN bus type of deal. Don't beat me up if I'm totally dumbing this down and making mistakes trying to explain it. Now, just one other thing that we have connected here, our trusty dime a dozen multimeter is set at 500 volts, which I hope is DC, and right now it's reading 0. It is connected to here. The top one is positive, the bottom is negative, but check your battery pack. I'm sure it's the same, but always check this kind of stuff. So if you look over here, see that little minus sign, negative? So the one on the left is negative, and if you look deep down there, it runs to the bottom one. And on this side, there's a plus on the outside. So the outside here, the smooth cable runs to the top connection, and that's the positive. So we will be monitoring this rather than putting any type of load on here. You know, I'm just using a multimeter to see what it does. I'm curious to see how much volts it sends when it's doing pre-charge, and then how much does it do when it's, you know, full blown. Okay, so that is going to be the hardware part. Okay, so now we're going to turn to the laptop here in the software. Double click the Arduino icon and launch the Arduino IDE, integrated development environment. So it's like a notepad on steroids, as I call it. It opens up just a generic program, like a new one starting once you just start coding, but we don't want to do that. We just launch it, and then we go here to the right side and we click this monitor. And I'm using an older version on my laptop. I have a newer one on my PC, but that's okay. Okay, so it's going to launch this monitor, and this is like a gauge, right? So we don't care about the program, we just want this little monitor. And in here, you just want to check your, make sure it says both new line and carriage return, and the baud rate of 115200. It's a common baud rate. So now we're looking at this blank canvas, right? So what do? Well, you type up here a question mark, as if you were doing help, right? And you hit enter, and bam, that brings up the menu. So this is really slick. I love this, okay? I'm an old Novell network guy. I remember the old Novell, like 311, I think 3.1. Blue screens, just super basic ASCII, always ran like a tank, you know, before they went to the GUI nonsense that always crashed and was slow. So I love this menu. Say what you will about it. It's like the Craigslist of EV programming, but I love it. So here we're looking at it, and the first thing I do is actually the last thing on the menu. It says toggle data display from SBox, right? So I hope this isn't going to make me look like a fool, but this menu is case sensitive. So if we type a little d and hit enter, nothing happens. But we want to do a capital D, and hit enter. And now it starts cycling through, and it's telling us the battery voltage, really 347, which is close to what our multimeter said. It's at 346, and then it's really not sending any amps. I mean, I think that's like milliamps, what have you. It's interesting why those were negative for a second minute. Okay. Okay, so that there shows us that it's working. Again, you might get a bunch of zeros here, so just go back through all your connections. Okay, so this screen is just going to keep scrolling and scrolling, and noobs with Arduino, you guys like me get frustrated, and what do? Well, there is a reset button on the Arduino board. It's this little guy right here. And so, sorry guys, we press it, hold it down for a second, and the LEDs will start flashing. And this is going to reset it and stop whatever it was doing, right? Now we have to be careful with this particular project because we're manipulating contactors here. But just for to stop it from reading, you can press that reset. And then sometimes what you have to do is you need to close the monitor, go back to your Arduino program, if you will, and open the monitor again. Now at this point, I don't know how much you guys know about Arduino, but sometimes you may also be frustrated and have problems because you didn't go to tools, and you need to go to board, and you need to select the board that you have. Do you see how mine says DUI and then it's the native USB port? The DUI has two ports. It has a programming port and a native port. It really doesn't matter, but I use the native. You can use it for programming and running it, so I just use the native. But this is what I was talking about, why I want you to buy the green card, so that it will actually find it here and you don't have to look for a bunch of crazy knockoff name cards. So you will select the Arduino DUI board, and then below there is a port, and that's really important. I wish they made all this stuff happen auto-magically, but you need to click in there and then select the COM port that finds the Arduino DUI. Okay, that's very important before this monitor will work. And sometimes you get errors that are meaningful, and sometimes they're useless. But those two things is something you have to do before you go in here to the monitor. So we'll bring up the monitor again, and then what do we press here to get the menu? Question mark. And then we're back in the menu. Now this is the cool stuff right here, okay? Now we get to hear some clicks. So we're going to activate the negative contactor, which is the lowercase n. Okay, and I'm going to put the camera closer to the safety box and see if we can hear it. I hope you guys heard that. And then nothing on our multimeter yet, because all we did is we closed one of the two connections. So we closed right now the negative, which is that side, the inside part, the negative contactor, and then here's the positive one. But before closing that one, we're going to pretend like we're going to be in the car, so we want to activate the pre-charge relay. So we're going to do R. And we're going to hit enter. And then there was another click, I'm not sure if you guys heard it, but now we can see 277 volts, okay? So it's, I think that's probably what it sends. Okay, and now we're going to go back and we're going to activate the positive contactor, which is P. And then again, I'm gonna put the camera here so we can hear it. And then when I did that, I wish I had the camera on the multimeter because that voltage really jumped to like 460. I'm going to try this one more time. So let's go back here. And you can deactivate all contactors and pre-charge relay, which is O. And then you heard another click because all of them now, I believe, opened up. And then now we're going to say, again, we're going to activate the negative. I think this is how it works in this order. So we're going to do negative. I'm going to put the camera on the multimeter and keep talking here. Okay, so that was negative and nothing happened. And now we're going to do pre-charge relay, which is the lowercase r. Another click, and then you saw I went like 67, then 277. Now watch what happens when I activate the positive contactor here. One second, I accidentally scrolled. Positive contactor is lower P, all makes sense. Again, I love this menu. Okay, watch. Did you see that? That like jumped to like 800. So this validates why we pre-charge the capacitors in the inverter with the pre-charge circuit, right? There's a resistor in that safety box, and it trickles in a bit of electricity, if you will, lower voltage, lower current especially, and tickles that capacitor in an inverter. Okay, so now we have them closed. So this is really dangerous. Now this is live. This is opened, or the contactors are closed, I mean, but this connection is now open. It's allowing electricity out of the battery box. So now I need to come back over here and say deactivate all of them, which is O. Sometimes they run out of letters, I think. There we have it. So another click, and just to confirm, we're back to no voltage out of the pack.